Hello everyone, so today we are going to be talking about prisms as a sort of introduction before we get onto the more complex parts of solid geometry. So our first prism that we're going to be talking about is the cube, and I'm sure you guys all know what cubes are, but a cube will look something like this, and all of their dimensions would be the same. So this side length, we call this side length S. This would also be side length S. This would also be S, and so forth, and this would also be S. And so there are a few things that we can figure out. We can figure out, one, the volume. And in this case, the volume is equal to, well, this face here is S squared. That's the formula for a square. And it has like what do you call it? A depth. It has a depth of S, so we would multiply S squared by S again to get S to the third power. And so our volume for this cube is equal to S to the third power. And so that's actually kind of interesting to note because volume is in 3D, right? 3 dimensions. And so one of our dimensions has a length of S, another one has a width of S, length of S, width of S. Width or length could also be substituted with height for one of them. Then we also have a depth of S. And so when you multiply all these together, you get S to the third power. This volume formula also applies to other shapes as well, as we'll see. We can also calculate the surface area, and to get the surface area, we have to draw a net of sorts. So if you imagine that we take this figure here and we kind of unravel it, starting from here, or like starting from this kind of plane, this plane right here, we'll have something that looks like this. So this would go up, and this would also wrap around here, 1, 2, 3, 4. So also wrap around here. So this would be our bottom, and this would be our top. And these are all our sides. And so this is kind of a net of all of this figure here. And so this is the total surface area, of course. And one of these parts, well, we know that this is S and this is S, so the area of this is S squared. And we have 2, 4, 6. We have 6 of these sides, and they're all equal, they're all congruent squares. And so our surface area would be equal to 6 to the S to the second power. And you'll notice with surface area is in 2D, right? Volume is in 3D, so we have S to the third power. Surface area is in 2D, so we only have S to the second power. And that works for units as well. So instead of saying S, let's say that we have S inches. Then the volume would be S inches. Well, I write it like this, but you would say cubic inches. And then for the surface area, you would write square inches. And this means the same thing. And these two are not completely different units, but these two are different units. One's working in the 2D and one's working in the 3D. And so I feel like I should just clarify this. Of course, cubes are not the only type of prisms that we can talk about. Instead of cubes, let's do rectangles, rectangular prisms. And a rectangular prism would look something like this. Did I do my freehand correctly? Hopefully. Okay, a rectangular prism would look something like this. Let's say that it has a height of something and a width of something, or length, sorry. A length of something, a length of this, length, and I'm not quite sure what kind of variables they use for this. Now I call this depth, so I'll still use D for depth, but I think there's another word for it. Like, perhaps this is width. Anyways, it doesn't really matter what kind of variables we use. But if we have a rectangular prism like this, the premise, or the way that we'd solve this equation is the same. So if we want to find the area, well, this face right over here is equal to HL. Now it has a depth of D, so we would get HL times D, and that would be equal to HLD. And you'll notice that this works even if we didn't start at HL, right? Let's say that we wanted to find the area of this face first. Well, this face has an area of LD, and it has a depth of H. That's the height. So if you imagine we'll take the sheet and then we fill it in the bottom, we'll still get LDH, which is the same as that. Let's see what's the standard that they use. Length, height, and width. Okay, so they usually call this part length, this part height, and instead of depth, they use width. So you might see it more like this. Length, length, width, height. I think, yeah, that's the standard way they write it. Anyways, just clarifying that. You can also draw the net for this in order to get, sorry, that was my fault. This is actually volume. You can also get the surface area, again, by drawing a net of this thing. So if you imagine that you kind of unravel this middle part, so you have the thick section right here. This is the top. Then you have one of the side sections, another side. Then you have the bottom. And then the bottom, and then you also have the, well, I'll put the side up here. And then you have the side surrounding top again. And then you also have these portions right over here, which are another side, SID, SID. And so you'll notice, let's try to find the area for the top portion first. Well, the area of the top portion is equal to length times the width, so this will be L, and this will be W. And if we want to get one of the areas of the side, so this side right here, well, we have the height times the width, so this will be H right here. I'm going to use a different color for this. We have the length right here, we have the width right here, we have the height right here, and you can continue labeling all the sides. This is also equal to height. This is, the bottom side is equal to width times length. This is equal to length. And you'll notice that if we want to get one of these sides, well, first of all, these two sides are equal, so we have a 2. And one of the areas of the sides is equal to the height times the width, so 2HW. Then we want to find the top and the bottom, and they're equal too. So we have the length times the width, so we have 2 length times width. And then we finally have these sides, and that's equal to length times the height. So that's 2 length times the height. And you might notice, whoa, we can actually simplify this. Or factor out the 2 at least. So 2 times HW plus LW plus LH. And that's as far as we're going to simplify for getting the surface area of a rectangular prism. And I want you, instead of memorizing these formulas, I want you to understand how we got to those formulas. For example, drawing a net and thinking about volume in terms of area and then depth, so that it pushes out into the third dimension. And you know, there are other prisms too, instead of just cubes and rectangular prisms. We also have triangular prisms. They look, okay, I'll sit on this side. Triangular prisms look like this. Did I draw this correctly? Yeah, this is what a triangular prism may look like. Okay, this is looking worse as I draw more lines. This is what a triangular prism looks like. And the idea for getting the volume is the same. First, we try to find the area of this triangle first. So this will be what we call our base. So we find the area of our base, and then we multiply it by the height, the width, whatever you call this. In this case, because it's positioned this way, it's the height. Of course, if you draw another way, like this, then this would actually be the width instead, and this is still the base. But anyways, we find the area of the base, and we don't know how to get this. I didn't label this part. But if you figure out how to get the area of this face right here, this triangle, this base, you multiply the area of this by the height in order to get the volume. And this works for, other things as well, not just prisms, by the way. Well, the same concept. It works for cylinders like this. They're basically bases, right? I mean, they're basically prisms, right? Except they're not prisms because it's a circle. But the way that we derive the volume formula is the same. And in terms of triangular prisms, you would also get surface area the same way by building a net. I know that the net looks a little bit more confusing when I actually draw it out instead of just visualizing in your mind. I encourage you guys to actually not draw this out and try to visualize where everything goes, because it's a lot more handy when you're doing problems like this. You have 2 bases and 3 sides, and you want to get the area of all of this. But the good thing is all the sides are rectangles, and you presumably already need another base to get the volume formula. Triangular prisms, that's one of them. I think you can also have irregular prisms, but I won't get too much into that. The idea behind finding the surface area and the volume of every prism is more or less the same. Of course, things become more interesting when you talk about cylinders and when you talk about spheres and, I believe, pyramids. Anyways, before we get into that, this is our intro to solid geometry by talking about prisms. Thank you guys for watching. I'll see you guys in the next video.